Welcome to homework.
In this problem, we have a simple circuit here that has a couple batteries, a couple voltage supply, and a couple resistors. And we asked a few questions about it, and let's see what they actually asked us to look into here. A whole lot of questions about it, and I'll just kind of, as I go through solving them, hopefully they'll all get answered here, or they will all get answered here. So one thing we can do, so we know that again has a potential positive here, negative here, positive here, negative here, so they're opposing one another. Um, so I've basically said that E2 has a voltage of -6 volts. So this one, so we get that sign take that sign into account here. Now if we go, if we do a loop around here, use the loop rule. The voltage drop across here is IR1, and the voltage drop across this one is IR2, and we have that equals to the voltage. Let's see here. That equals, actually, I think I'm going this way. Sorry. So that equals to the voltage gain across here, and plus the voltage gain across here. But that one is negative. So we know everything in here except for I, so we can solve for I, and that comes out to be half an amp. So we have half an amp circling this way around the circuit. So yeah, I went counterclockwise in my loop here. So we got a positive amp, and that makes sense because again, this battery has a higher voltage than this. So if we lump them together, we'd have a net 6 volts going this way. So we'd expect the current to be flowing counterclockwise. Again, also given the resistance here. This one has 8 ohms, and this one is 4 ohms, and this one is 8 ohms. So again, we can just plug all those values in, and we get half an amp of current flowing through. Now they ask us something about the power being dissipated through the resistors. And so the power dissipated in a resistor is, well, one way to write it is I squared R. So we know what I is, and we know what R is for each of the resistors. So for the first resistor here, we have I squared, so that's winds up being 1/4, and R is 4, so we wind up with 1 watt of power being dissipated in this resistor. In this resistor, again, I squared is 1/4, R is 8, so we wind up with 2 watts of energy being dissipated in resistor 2. So we got a total of 3 watts of power being dissipated, or 3 joules per second, 3 joules of energy per second being dissipated. Now we can also figure out how much what power the batteries are producing. So the energy being supplied by them, and that's the voltage times the current. And so in this battery, we have a voltage of 12 volts, and we have a current of 1/2 amp. So we have let's see here, we have 6 watts of energy being supplied by this one. In this one, we have the voltage is -6, so the current is flowing in the opposite direction of the potential of the plus minus. So it's flowing in the opposite way. So this battery actually is absorbing energy, which is part of one of the following questions. And that's absorbing 3 watts of energy. And so notice that the total energy output, which is 6 watts, output by this, 3 of it's being absorbed here, and the other 3 is being dissipated as heat by the resistors. And so they asked us, which of these batteries is supplying or absorbing energy. So energy is being supplied by this one because the voltage, the current is flowing from a lower potential to a higher potential. And so then this one here, we have the current flowing from a higher potential to a lower potential. So that has, and that's one, that is actually, we're pushing energy into here. So really what we're doing here is we're charging this battery from this battery, but we're losing half of that, half of the energy to these resistors.